All right, so we're done with naming, and we're gonna move on to something pretty important and fundamental to chemistry. We're gonna talk about chemical reactions. When things get mixed together, what happens? Okay, and very specifically today, we're gonna balance chemical equations. This is something that needs a lot of practice. It has to do with numbers. You got to make two sides balance out just like on a scale by slapping numbers on until they're the same. Okay, so we're going to first of all learn why we have to do this, the law of conservation of mass. Then we're going to learn how to write chemical equations. And then lastly, we're going to balance chemical equations. Okay, so by the end of this class, you should know how to write a chemical equation, slap numbers on it so that it is balanced. You don't have more on one side than the other, and you can explain why you have to do that. So let's start with chemical reactions. So we learn about chemical change versus physical change, and a physical change is where something happens but you still have the same thing afterwards. It's just now in a different form, like ice melts into water, but that's still H2O. That didn't change. But a chemical reaction, afterward, you make new substances with very different properties. So for example, a burning coal, you have a lump of carbon. After you burn it, you don't have that anymore. You now have carbon dioxide in the air, which is something completely different. Okay, so burning fire, souring milk, all of these are examples of chemical reaction. And we can represent chemical reactions kind of like a recipe, really. So just like baking, if you want to make something in baking, you mix ingredients together, you stir them, and you get your product. Okay, that sounds pretty simple, right? So you want to bake something like a loaf of bread. You just take some wheat, some flour, you mix some sugars, and you pop it in the oven. There you go. You have a piece of bread. Okay, it's a little bit more complicated than that, but that's the general idea, though. Ingredient 1 plus ingredient 2, they combine to make your product, whatever you're baking. A cake, a baguette, I don't know, bread, muffins, whatever. Okay, so that's baking. Exact same idea for chemical reactions. And we can represent that using one of two ways. You can use a word equation. So basically, in words, you describe the names of your reactants. Which thing is added to which other thing to give me what product? So tell me the names. And if that's annoying because you got to write their full name, you don't have to. Write their chemical symbols instead. So use the formulas for a chemical equation. Okay, so we learn how to name and we learn how to write the chemical formula from seeing the name. So you're supposed to know how to do both. And also you have these two words, reactant versus product. A product is something that is produced. Get it? Product. You make it. So that's what comes out afterwards. Reactant is something you mix together to get to the product. So those are your ingredients. We call them reactant, and they're found on the left side. Okay, so let me give you some examples here. Here's one. Sodium carbonate, that's the name of the compound, plus calcium nitrate, that's the name of the other compound. I color-coded this, red and green. And they mix together and their products become sodium nitrate plus calcium carbonate. Okay, notice there's a little mix here. Sodium was with carbonate, now it's with nitrate, and carbonate is now with calcium. You kind of like you did a switch, a little switcheroo. You take one, I take one from you. That's the word equation, the names. Very often in chemistry, we don't use word equations, we use chemical equations. So the exact same thing expressed in chemical formulas. Sodium carbonate, that is Na2CO3, okay, which is something that we learned. Sodium is Na, Carbonate is a polyatomic ion, that is CO3. For every CO3, which is 2 minus, you will need 2 sodium atoms, which is 1 plus each. So that's why Na2CO3, okay, plus calcium nitrate. Calcium is Ca with the 2 plus. Nitrate is a polyatomic ion that has a 1 minus charge. So that's why you need 2 of them to balance the calcium. So you get sodium nitrate, NaNO3, and calcium carbonate. So that's the idea of a chemical reaction. And notice that we use an arrow, a single arrow that points from the reactant to the product. It is not an equal sign. I see so many students using a chemical equation, they put an equal sign, just like in math class. No, they're not equal. In math, 1 plus 1 equals to 2, because literally 1 plus 1 is 2. It's the same thing. But these are not the same thing. The products are different from the reactant. That's the whole point of a chemical reaction. You're supposed to get something different. So no, they are not equal. Please don't put an equal sign. On the left of the arrow, you have the reactant. On the right of the arrow, you have the products. Okay, so far, does that make any sense? Okay, what are these? Okay, I'm underlining these little bracket thingies. You have AQ, AQ, AQS. Anyone know what they are? Anyone learned this before? The state. Okay, yeah, that makes sense. These are the states. I don't mean the United States. I mean, what form is it in? Solid, liquid, gas, or aqueous. There are 4 states here. So these are the state symbols. Okay. S for solid. Y'all know what a solid is. A solid is, my desk is a solid. You know, your face is a solid. A liquid is like water is a liquid, or alcohol is a liquid. So that's L. Gas. That's very intuitive. The air that you're breathing, it's a gas, so bracket G. The last one is a little bit different. AQ stands for aqueous. That means dissolved in water. If you have something dissolved in water, it is not a liquid, it is aqueous. There's a difference. The alcohol that people drink, they're aqueous solutions. You go to the store, well, you can't go to the store and buy alcohol, but your parents can. They go to the store, they pick up a beer, there it is. The beer is alcohol dissolved in water. That's very important. You're not drinking pure alcohol. You would drop dead because that's very toxic. Okay, in fact, you can make the alcohol more concentrated, so that's why drinking a beer versus drinking vodka, that has different effects. Okay, because one is more concentrated in the alcohol, and then in the lab I have 99% alcohol. Yeah, no, you're not. Nobody is supposed to drink that. So they come in different concentration. If it's like 99.9%, we just call it liquid alcohol. You can burn that. You can light it on fire. But the vodka from the beer store, you can't light that on fire because there's a lot of water mixed in there. So that would be aqueous. Okay, so please understand the difference between aqueous dissolved in water versus just a liquid, just a liquid form, no water, unless it is, of course, water. Okay, so for a chemical equation, you will need the state symbols to tell me what state they are found in. So let's try this one. So write the word equation and the chemical equation for the reaction below. So here's the reaction. Aqueous sodium ions react with aqueous chloride ions to form aqueous sodium chloride. So basically, from that sentence, you're supposed to give me a word equation and a chemical equation. It's not as simple as you think. There are many little details here. So first of all, the word equation. What do we need? We need sodium ions. So here I highlighted sodium ions. The word ion is very important. It's not sodium, it's sodium ions. Sodium is just Na. Sodium is very explosive. Okay, but sodium ions are not. Sodium ions are sodium atoms that have already lost an electron. So they're pretty harmless. They are not supposed to react anymore. They're done. Okay, so sodium ions and chloride ions, same thing, not Cl, but Cl with a negative sign. Does that make sense? And then they form sodium chloride, which is salt. So I highlighted all of the chemicals here. And there, that's my word equation. Sodium ion plus chloride ion, arrow, sodium chloride. Does that make sense? Just put them together. And please don't spell these wrong. You literally copy it from the question. Please don't copy that wrong. You cannot spell chemicals wrong. And then the chemical equation is the formula, the chemical formulas for each of these. So sodium ion would be Na with the plus charge. You have to have the plus charge. Without the plus charge, it is not an ion. It is a pure metal. Okay, so sodium plus. Chloride ion is Cl minus. And then, of course, salt, sodium chloride is NaCl. It's a 1-to-1 ratio. For every 1 plus, you have 1 minus. So it's 1 and 1. Now, the AQ needs to be there. The aqueous. These are all aqueous. So that means in your chemical equation, you must include bracket AQ for every single thing. It follows the chemical compound. It has to be inside of brackets. If you don't have those brackets, then we assume it's part of the chemical, which it is not. It's simply telling you what state it is found in. All right, so do we have any questions regarding how to write word equations, how to write chemical equations? Okay, I'm not seeing any questions. So let us move on to example 2. Example 2 is a little bit harder. I'll give you a chance to do this, and then I'll take this up with you. So you have to read it carefully. Solid lead metal reacts with oxygen gas. This is telling you what state they're in to form solid lead-4 oxide. So write the word equation and write the chemical equation. So I'll give you like 2 minutes, and then I will show you the answers to this. What? You guys good? Okay, I'm gonna take this up. The word equation is relatively easier compared to the chemical equation. All you have to do is just copy them down and write them in an equation format. You have lead and you have oxygen. What did you make? Lead 4 oxide. So those are the three chemicals. So for the word equation, just put them in. Lead plus oxygen, arrow, lead 4 oxide. Okay, nothing fancy. Don't change anything. Notice that I didn't put lead metal. That's not necessary. Just lead because metal is not part of the name. Oxygen gas, I only put oxygen because gas is not part of the name for oxygen. Gas is telling you that it's a gas. You don't need that for a word equation. All right, but for a chemical equation, you have to use a periodic table. Find their chemical symbols. Lead is Pb, solid. Oxygen, O2, not O. A lot of people write O for oxygen. It is O2 because it's one of the special 7 diatomic elements, and it's a gas, so G. And lead 4 oxide, so that's where naming skills come in. You have to know that lead 4 oxide is PbO2. Lead 4 is a 4 plus. Therefore, you would need 2 oxygens. All right, so of course, the state symbols, solid, gas, solid. Solid lead metals. So that's why you have the S. Oxygen, gas, you have the G. And solid lead 4 oxide, you have the solid S. Okay, and that would be the full chemical equation. You need everything. You need the solid, you need the gas, you need the solid, you need the arrow, and all the correct chemical symbols. Okay, is that clear, ladies and gentlemen? You will probably need quite a bit of practice with questions such as this one. Because you're going to deal with different elements and compounds every time, and you have to find the periodic table. You got to figure out what the chemical formula is. So that takes some practice. So here's another one. Hydrogen gas reacts with nitrogen gas to form ammonia gas. Okay, write the word equation, write the chemical equation. So you have to understand what hydrogen gas is. You got to know what nitrogen gas is. And finally, what is ammonia gas? So again, I'll give you like a few minutes to try to work this out. And then I'll take this up. And please share your answers if you're finished. Did anyone finish? Yeah, okay. You even balanced it. That's great. Yeah, I wasn't expecting you to balance this. I just wanted the word and chemical equations, but yes. Okay, I think that was enough time. If you don't get it, then yeah, you don't get it. I need to explain this. So first, write down the word equations. Well, you have hydrogen, you have nitrogen, and mix them together, you have ammonia. So the word equation is just simple. Add them up, the words. Hydrogen plus nitrogen, you get ammonia. The tricky part is the chemical equation. Hydrogen is H. Okay, but it has to be H2. It's one of the 7 diatomic elements. It always comes in pairs. Same for nitrogen. It is not just N, it is N2. It comes in pairs. And then ammonia is NH3. You have the gas, you have the gas, and you have the gas for all of them because they're all gases. Okay. Now you might be asking, why is there a 3 and why is there a 2 in front of some of those? First of all, the number in front of each compound, they're called coefficients. All right, it's just like in math. You can have a number in front of a letter, like 3x, 2y. It tells you how many x's you have, how many y's you have. Same thing here. It tells you how many hydrogens you have, how many ammonias you have. So these are coefficients. They tell us the ratio of the compounds in relations to each other, meaning that for every 3 hydrogens, you only need 1 nitrogen, and you will create 2 ammonia. Okay, so we're going to learn a little bit more about these numbers. And these numbers are not randomly assigned. You need to know how to figure out what those numbers are. And that's the idea of balancing equations. So where do the numbers come from? It comes from this statement right here. The statement says, matter cannot be created nor destroyed. It can only be converted from one form to another. Okay, you can't create matter from nothing. You can only create matter from something that already exists. You can change it, but you can't create something from nothing. And you cannot take something and utterly annihilate it. You can't destroy it into nothing. You can blow it up, you can burn it, you can do whatever you want to it, but there's still remnants left. Okay, if you want to get rid of your textbook after this course, yeah, sure, you can burn it to ashes and feed it to pigs. But then there's still something. There's still ashes. It's still something that the pigs ate. There's poop. It's been converted into something else, but the atoms are still there. You can never get rid of an atom. So that's the idea here. This is the law of conservation of mass. You cannot destroy atoms. They will always be there. Okay, and you can't create atoms from nothing. So then, this means that in any chemical reaction, you can change what you have, but you can't change the amount of what you have. So the mass of the reactant will always be equal to the mass of the products. Whatever was there, whatever atoms were there before, they will be there afterwards. It's just now they're rearranged differently. They've been reassigned. somewhere else. Okay, so if you burn coal, you had coal. Now, after you burn it, you have something else. The residue, those black soot, those ashes, and the smoke, the carbon dioxide that's been released into the air, all of those atoms are still there. It's just now they're in the air. Okay, so here is the chemical formula. You're burning coal, solid carbon is being reacted with oxygen gas. That's the idea of burning. You get carbon dioxide. Look, you have one carbon. You have one carbon. You end up with one carbon in the carbon dioxide. You have two oxygens before the reaction. You have two oxygens after the reaction. It's just now they're all sticking together, but the mass is the same. Okay, it's because of this idea that we have to balance chemical equations. Here's another example. You're burning natural gas, methane. Methane is CH4. Let's say that you use 16 grams of methane. You burn it with 2 times 32 grams, so 64 grams of oxygen. What do you get? Well, that burns into carbon dioxide and water. You would get 44 grams of carbon dioxide and 36 grams of water. The numbers should add up to the same numbers before and after the reaction. Okay, if you count the number of atoms on the reaction side before the arrow, how many carbons do you have? Well, one. Just look, one carbon from the methane. That's it. How many hydrogens? Well, 4. The methane has 4 hydrogens. Oxygen, they don't have hydrogens, so 4. How many O's? Well, look at the picture. You have 2 oxygen molecules, so O2 is 1 oxygen. You got 2 O2s, so that means 2 times 2, you got 4 oxygen atoms. Okay, that's before the reaction. After the reaction, check out the products. You have CO2 and H2O. How many carbons do you have? Well, count 1. It's inside the CO2. That's the only carbon. How many hydrogens? Look at the white ones. H2O, they both have 2 hydrogens for every water, so 4. And the oxygens, well, 2 on the carbon dioxide, that's 2. The water molecules each have 1, so that's a total, again, of 4. The atoms didn't change. You have 1 carbon before, you have 1 carbon after. You got 4 hydrogens before, you have 4 hydrogens after. And the same thing, 4 oxygens before, you get 4 oxygens after. Notice that the compounds themselves change. You don't have methane, you don't have oxygen anymore. They now became carbon dioxide and water. But the number of atoms of each compound, those atoms remain the same. And the mass, if you measure their weight, they should be the same. Okay, so again, here's another example. Consider this. Hydrogen gas reacts with chlorine gas to form hydrogen chloride gas. If you just count, they're not the same. Before the reaction, you have H2, 2 hydrogen atoms, plus Cl2. You got 2 chlorine atoms. That's a total of 4 atoms. But after you have HCl, H plus Cl, you have 1 of each. See, you're missing something. So what we do is we easily fix this by adding a 2 into the equation. So H2 plus Cl2, you get 2 HCl's. If you double them, you get 2 molecules of hydrogen chloride, you got 2 hydrogens and 2 chlorines. Now they're the same. We call this balancing chemical equations. You put numbers in front of the chemicals so that you end up with the same number of atoms on each side. Okay, that's the idea of balancing equations. You're not supposed to change the equation itself. Do not change the compounds. Don't think, I don't like hydrogen, I'm going to change that to oxygen. That's not what we're doing. You have to only put a number in front and nowhere else. All right, so here are the steps for balancing equations. Don't memorize this, but understand what your goal is. I wrote out the steps for those students that need instructions. Just read it and just follow these steps. But if you don't like reading, I'll show you what happens. Okay, so basically, step one, you have the equation in front of you. There are no numbers. Step two, you start counting. How many atoms do I have for every one? And then you start to multiply the formula. You slap numbers on until they're balanced. And then you write the balanced equation. This requires a lot of practice. I've done so many of these when I was in school. And the more you do, the faster you can do this and the more easy this becomes. But I've done so much, I come up with my own strategies in how to do this quicker. And there are quick ways and there are slow ways. But what I'm saying is I've developed some rules of thumb that I follow to make my life easier. So first, I always balance the most complicated compound first. If I see something big that gives me a headache, I'm doing that one first. And then I worry about the easier ones later. If I see a unique atom, that means it only appears once in the equation. I focus on that one first. If you see an element like just O2, do that last. And then if you have a polyatomic ion, like a sulfate, treat it as a sulfate. Don't break it up. And this will make a lot more sense if we actually look at some examples. And we're going to apply these rules to help us balance. So again, I copied these rules here for your reference. But the question is, write the balanced chemical equation for the reaction of sodium and oxygen to produce sodium oxide. So this gives you a word description of what happened. You need to write the equation. Sodium in oxygen to make sodium oxide. Well, I highlight those keywords. Sodium is Na. Oxygen is O2. Sodium oxide, that's Na2O. Ta-da! That's my skeleton equation. Skeleton means there's no flesh on this, just bones. I don't have any numbers in front. I just have sodium plus oxygen is sodium oxide, Na2O. Step two. Okay, I have this. By the way, you have to get step one correct. It is Na plus O2. If you write Na plus O, you're going to get it wrong. It has to be O2. How many sodiums do I have? On the left side, you start counting. 1, that's it. In the reactant side, you only have 1 sodium. How many oxygens? 2, because O2 has 2 oxygens. Does that make sense? And then you count the products. How many sodiums are in the products? Well, there's a 2, so there's 2 sodiums. Oxygen, there's only 1. Now, obviously, this is not balanced. Sodium atoms are supposed to be equal before and after. Oxygen atoms are supposed to be equal before and after. They're not equal. So now what do? You put numbers in front of each letters, in front of each compound, so that you multiply by something, so that they become the same. You start with the most complicated compound. So I look at this equation. Na2O is the biggest thing in the equation. I'm going to start with that. I noticed that, wait a minute, I only have 1 oxygen here, but over there on the other side, I got 2 oxygens. So I got to double this to match the oxygens. See what I mean? It's like playing poker. They bet $100. I got a call by matching the $100. So I got to double it so that I have 2 oxygens on this side. But look, you double the whole thing. You don't just get to double the oxygen. You also double the sodium. So instead of 2 sodiums, you now have 4. Just so that you can have 2 oxygens. See what I mean? All right, so let's take a scan. The oxygens are balanced, no problem. The sodiums, on the other hand, they're not balanced. I got 4 sodiums on the right now. On the left, I got 1. Well, that's very easy. I'm just going to put a 4 there. Now I have 4. You see what I did? I balanced the sodiums on the left by adding a 4 in front. So now there are 4 sodiums instead of 1. let's do a quick recap. Sodium 4,4. That's good. Oxygen 2,2. That's good. We're done. That is the final balanced chemical equation. And that's the answer right there. Okay, do we have any questions regarding this whole process? Everybody's good. Okay, I'll show you more examples. But basically, we follow the same strategy, just different compounds. Okay. All right, here's another one. Read the question. Write the balanced equation for the reaction between copper metal, okay, in silver nitrate to produce copper to nitrate and silver. So step one, figure out what the equation is. Well, I got 4 things in here. I got copper, I got silver nitrate, I got copper to nitrate, and I got silver. You just take out your periodic table. Copper is Cu, silver is Ag, nitrate is NO3. You put them together in an equation. So copper, Cu, plus silver nitrate, that is AgNO3. Silver is Ag, NO3 is nitrate. There it is. Silver is 1 plus, NO3 is 1 minus, so it's a 1-to-1 ratio. What do you make? You make copper 2 nitrate. The copper is a 2, so you need 2 nitrates, plus silver. Just silver, Ag. That is our skeleton equation. We need to then count how many coppers do I have on the left, how many silvers do I have on the left, and how many nitrates do I have on the left. Notice that I didn't separate the N and the O from the nitrate because it's not necessary. Treat polyatomic ions like nitrate as one single entity. So it's easier to keep track of them unless they break up in the product, which they don't. The products still have nitrates, so just treat it as one big unit. So let's count. Copper on the left as uno. Silver, again, uno. And then nitrate is uno, one of each. Okay, on the right side, you have uno for copper, uno for silver, but look at the nitrate. There's a little 2, there's a bracket, so that's a dos. So you have 2 nitrates. That's the only thing that isn't balanced. This is almost balanced already, but almost is not good enough. It has to be perfectly balanced. So you better fix it. How do you fix it? Well, this is kind of a no-brainer because there's only really one thing you can do to balance the nitrates. You got 2 on the right side. You have 1 on the left side. Of course, you double that one so that you get 2 nitrates, right? So now you have 2 nitrates and 2 nitrates. Yay. But oh crap, I doubled the silver because silver and nitrate, they come together. Right? By putting a 2 in front, you have 2 nitrates, no problem, but now you have 2 silvers. Like, oh, what do I do now? You go to the other side and you balance the silver again. I got 1 silver, but I need 2. I just look at the silver. Okay, so I'll put a 2 here. And now I have 2. Okay, let's do a recap. Copper, okay, 1, 1, that's good. Silver, 2, 2, that's good. Nitrates, and we're good. So that's the answer right there. That's your final balanced equation. So copper plus 2 silver nitrates, you get copper to nitrate plus 2 silver metals. You see how this works? Any questions? Okay. Okay. So now it's your turn. Do that with these. Okay. And when you're done, post your numbers into the chat. If it's a 1, you technically don't have to write a 1, but in the chat you do because I need to know that you have all the numbers. So, and then after that, we'll click that link and we'll play that game on FET. So I'll give you a few minutes. Make sure you balance this, and I'll take this up. Yeah, that's usually an issue, pressing enter by mistake. No one has it all done. Okay, you're done until E. All right. You know what? I'm gonna take it up row by row, because there's still something else I want to do after this. For A, what are the numbers? How do you balance A? Anyone? You can type the numbers into the chat, please. Folks. So you're telling me nobody got A?
Wait, just like the answer?
Yeah.
I don't know if I did it right, but I have it.
Okay, what do you have?
Oh.
Okay. 4, 5, and 2. Yeah, that seems to make sense. Let's double check. Okay, so the way I did this is I showed my steps. So first, I will balance the oxygens. This one is a bit weird because look, there's 5 oxygens. So you can't really multiply by number to get from 2 to 5 unless it's like 2.5 a decimal. You can't have a decimal, by the way. So you multiply by each other. It's like cross multiplying in math, finding the common denominator, that kind of thing. So 5 oxygens to diphosphorus pentoxide, and then of course you balance the phosphorus. You need 4. So 4, 5, and 2. That is correct. So yeah, the first one is actually a tricky one. The second one is a bit easier. What's the second one? What are the numbers, folks? You don't have to write the whole equation. Just tell me the 3 numbers. Okay, this is not good. If most people are not responding, that means you don't get it. Okay, I see it. So basically just put a 2. Yep. Yeah, that one is pretty simple because if you just double the right side, you just have what the left side is. 2 potassiums, 2 oxygens, and 2 hydrogens. You see that right there? C is long, but it's not necessarily difficult. What are the numbers? Remember the strategy here. Go with something complicated first. Two, 3, 6, and 1. 2, 3, 6, and 1. I think that's correct. Yes. So what I did was I put a 3 on the potassium sulfate. Now, why did I do that? Because I see that on the other side, I have 3 sulfates. I only have 1 sulfate on the left side. So I have no choice. I absolutely have to put a 3 there. Otherwise, it's not going to balance. But when I do that, I have another problem. I need 2 aluminums. Okay, because on the right side, again, you have 2 aluminums. I only have 1, so I put a 2 in front of the aluminum bromide. So I do my count here. I got 6 potassiums as a result and 6 bromine. So I have a 6.
It's fine. I just.
Sorry, I think your mic is on.
Oh, sorry. Sorry, my mom came in to talk to me.
Okay, so you see how this works? If you see a big question like that one, you think slowly, step by step, break it down into smaller processes. Don't try to balance everything at once. You do it one at a time. Okay, so I started with the most complicated thing. So, yep, that's also the right answer. Okay, D is the same idea as C. D, I look at the polyatomic ion, the hydroxide. I got 3 of them on the right side. I got 1 on the left side. I slap a number 3 on there so that I have the same number of hydroxides. Okay, same thing. The chloride, I got 3 on the left side. I need 3 on the right side, so I'll put a 3 there. And it just so happens that the sodiums both have 3s because I put a 3 in front of both sodiums, and that's balanced. Yep, that one's correct. Okay, you see, all of these questions require you to do the same thing over and over again. So E, you should go with the polyatomic ion, the more complicated one, NO3, NO3. Oh, perfect, they're 1 on 1. Okay, you have NO3 on the left side, 1 NO3 on the right side. That's already balanced. You don't have to worry about that. So what's not balanced? The silver is not balanced. So the Ag, there's 2 on the right and 1 on the left. So what you do is you put a 2 there, you balance the silver, but then all of a sudden the nitrates, the NO3, are not balanced anymore. So that means you need to balance it by putting a 2 on the other side. You see how this works? And E is a tough one. E, there's 3 things on the right side, only 1 thing on the left side, but don't worry. Just do this slowly. Nitrogens. You see that there are 2 nitrogens on the left side because the NH4, the ammonium, has a bracket 2. That means there's 2 of them. Okay, let me put a 2 on the nitrogen. And it turns out the moment you do that, you're done because everything else is balanced. And it looks difficult, but really putting a 2 finishes the question. Okay, so you guys obviously need a lot of practice with this, which is normal because you're learning this for the first time. Practice makes perfect, or the saying goes. Well, it doesn't make perfect, but it does make you better. There's a link that we're going to click. It's a game of balancing equations. So I'm first going to stop this lesson, and we'll click on that link.